What's up, Cass? Day 25? Yeah. Halfway to 50. Last stream I ended off dealing with like a weird bug with white space for the Lexer. And I chose to be a bad student in my classes today and instead work on it. So now we have a much more polished Lexer that actually works. The key was I just had to like Lex white space here and here, and then also in the Lex white space. I didn't realize these weren't two character things. \n is one character somehow. So I don't fully understand that. So we were never really getting into here when we were doing like self.peak2 equal it. So yeah, polish some stuff up here. Most of all of the logic is pretty much the same though. And then I added some type checking stuff just so I could read from a file, like this. This is pretty much just saying like you're either reading from a source or you're reading from a file. You are never reading from either. I mean, you're never reading from both. That's just not allowed. And then like I did some like printing stuff, and I made a test suite. So I did a little bit off camera, but not a huge amount, to be honest. Do I have anything else on this project? Not yet, but today we'll pretty much just be doing the parser, which means we actually have our string of tokens now. Like, if we run this, we have like all the tokens, which is quite cool, you know? Good stuff. So we'll get after that once we do some LeetCode. I was looking at this one, the LRU cache. I was trying to think about it in class, and I couldn't come up with a solution that I really liked. So I looked at the solution for this, and it makes like a good amount of sense. So I'm gonna try to implement this later when I like don't just have it in my memory. And essentially, the basics that I needed to know is just doubly linked list and hash map for the cache. What I need to think more about is like how. One thing I didn't really understand is why we were removing and inserting. I think it's to like replace the positioning in the thing, like with a new key. But I'm not too sure. Because like, to me, I guess remove and insert does like, it changes the linked list. So yeah, that makes sense. Does make sense. Because you're not removing it from the cache, you're moving, I answered my own question. But regardless, I'm going to, I don't really know what I want to do. Two pointers, I already did that. Let's maybe try this one. Let's do a linked list one. I remember doing some of these, but I kind of already forget them. Trees, or let me do a graph problem actually. Graph valid tree, or clone graph sounds cooler. And then maybe we try like one dynamic programming thing. Let's try house robber. I've heard of that one before, but I've never done it, so I probably should. Yeah, let's get started. Clone graph. Given a node in a connected undirected graph, return a deep copy of the graph. Each node in the graph contains an integer value and a list of its neighbors. Interesting representation of a graph. Okay. The graph is shown in the test cases as an adjacency list. An adjacency list is a mapping of nodes to lists used to represent a finite graph. For simplicity, node values are numbered 1 to n, where n is the total number of graphs. Nodes in the graph, okay. Index of each node. So we're returning nodes, we're not returning an adjacency list. Yeah. Okay. So this seems like you're just traversing, no? It kind of just seems like a BFS. And just traverse the whole thing BFS-wise, and then just spit out a deep copy. Is there... I'm seeing that the node is optional. So it seems like a good place to start would obviously just be if not node return node. Wait, is the input node will always be the first node of the graph? Okay. Okay. I mean, it seems kind of normal. So we just like create a root, which is a node with val equal to 1, because it said that we're always starting with 1. Just do the basic DFS thing where we're taking in a deck. Just say Q is equal to our deck that just says the root for now. Do I need to keep track of a visited? I think so. Visited equals set. Are nodes hashable though? Are the indexes? There are no duplicate edges and no self loops. Val is 1 to 100. Number of nodes in the graph is max of that. Okay, I'm pretty sure we actually don't need a visited set, because you could never visit something twice with BFS if there are no duplicate edges or self loops. Because like this node can't ever reconnect to this. You can only come from one thing, I think. Like if you have an in degree of 2, at least I don't think that I need one, so for now I'm just not going to use one. Val Q cur equals Q dot pop left. Let me think. What are we doing? Just doing some LeetCode right now. And then we're gonna JSON parser later. Equals 1. Or no, this is just node. Yeah. And then what we can do is oh shoot, I'm thinking about this wrong. So we're gonna add to the queue, and then pretty much need to get all Like, we essentially need to do a level order traversal. Right? That's what it seems like to me. I'm trying to think. Why is my computer glitching? Okay. So our current one is popping at the queue. So we need to be making copies. We hit it like with a result. Why am I thinking of this wrong? It's just like we loop through the neighbors of the current node from this, like from the given, and then we build that in our thing. Okay, that's where I'm getting confused. Okay, yeah. So our result is actually just going to be result equal, we'll just make like a dummy node. And then we can do I need a dummy node? I'm kind of thinking of this like a linked list, but I don't know if that's the right way to think about this. I definitely should have whiteboarded this way more. It's never too late. So if we have something like, what do they give? One, two, three. So my mind says we take this node, we add it to a queue, and then when we pop it, we're going to make our own version of that node. And then when we loop over the neighbors, this should be in a different color. So we initially copy the value to make our new node. And then we loop over the neighbors, which could possibly be these things, and then build it from here. Like that's our self.neighbors list. Yeah. And then at every point, you're just building the node and its neighbors, I think. So let me try that. But I think we do need an original dummy one. Off the top of my head, I don't have nightmares with yeah. I agree, Lauren. Also, what's up? Hope you're doing well. The only thing is, how do we like make these nodes is the thing I'm kind of... It's the only thing I kind of don't exactly know. So how do we like instantiate them and make sure they're tracking with each other? Because from here, like when we first, we need some, I think we need a dummy. Like it just my head is going to a dummy. I don't entirely know why, but I think we have like one node and then that points us to the start. And then on each one, then we're copying. But it's like, how do we link them? I guess because we're adding them to the deck when we create them, and then we're popping. Okay. Maybe I set this one to be we just have like 0, and then the neighbors are just a list of root. That's stupid. Or can we just call root equal node? Because I essentially need like a deep copy of the first one. Maybe we do dot neighbors. No, we need this to be a dummy. Oh, can we do something like this? This has been very bad. I've not been doing good practice here. I did not think through this problem enough. I thought I had it and I just didn't. Okay, so cur equals q.popLeft. We're then gonna make our own new node with we don't really need to do it there. Well, equals, we don't even need to store that. For neighbors and cur.neighbors. Should actually be an I in range. At each point, we need to make a list. Neighbors equals that. Neighbor node equals a new, like, we make our own new node of neighbor.val and neighbor.neighbors. This is a very stupid way of doing this, but whatever. And then we need to q dot, is it push? Is it push back? Oh, is it append? Seems like I want append. I think it's append. You dot append the cur neighbor. new neighbors to append our entire new thing. And then we are going to have to loop through the original neighbor again. And then at the end of here, our new node is going to be a node with cur.val and new neighbors. Right? But the thing is, I still haven't figured out is, I think this links. Because we're creating our own node. No, this is a nightmare. I'm not doing this stuff. I was doing this completely wrong. DFS? Why do we need a hash map? This was real bad. Why didn't I think of this hash map at all? So it's just mapping the old node to our new node. Wow, that was real bad. Oh yeah, all right. I guess DFS makes more sense. Why did I think I could just, mistakes are killing me. Okay. Well, that's why we practice. Mapping at node. That's the copies. Make our own new thing. And then that node maps to our copy. And then for the neighbors, in the node.neighbors. DFS the whole thing, and those are its neighbors. You're right. You're right. Thank you. Yeah, it was just like, I don't know why my muscle memory with DFS is always like the first thing should be like a not condition. Because like typically you're going to a base case. Alright. That's definitely my worst problem in a while. I was way off with what I was doing. But the solution makes so much sense. Yeah. It's quite annoying actually. Can you do the BFS? I mean, like, just I should probably do it just for the sake of doing it. I was originally trying to do it with BFS, but it's because my brain was going to like, when I see like a graph that can be like mapped like this, it made more sense for me to like just do the breadth. But I mean, both are valid actually, at the same time complexity. BFS is just a lot simpler. Well, it's essentially the same thing. It's just like start off with the root node, and then just go through the neighbors, create the clone, add the clones to the neighbors, and then append the neighbor to the queue. This is more what I was thinking, except I didn't have this mapping. And that's just like this, essentially like a visited kind of thing. Oh no, you need that because you don't want to be like, you're always trying to make a deep copy, but you don't want to make 2 deep copies of the same node. Makes sense. Okay. House robber. I know this is a DP one, so scary. We're given an integer array nums, where nums at I represents the amount of money ith house has. Okay. Projects you working on at the moment? Food app. I actually should update it. Food app was my biggest one, but to be honest, it's mostly done. I feel like it's quite polished, and I haven't had any complaints from like any of my friends that actually use it. So right now, long way to say, I'm working on a JSON parser right now, actually. We were working on the Lexer for the past couple days, so now I can like essentially take in a JSON string and then get like all of the tokens, like we tokenize stuff, and then I'm gonna make the parser part later today. Should be relatively easy. But yeah, this was definitely the bigger project. This took me like a month or 2. Nice, like the front end of a compiler. Yeah. But yeah, this has. I'm very proud with how this came out actually. Like a bunch of stuff responsive to mobile. Very quick, like compared to the actual Dyn on Canvas app, like this is lightning fucking fast, which is cool. Amount of money ith house has. Houses are arranged in a straight line. Okay, so ith house neighbors with I minus 1 and I plus 1. Makes sense. Literally inspired me to make a web with. Oh, nice, man. Nice. It goes really fun. Like, I was surprised I've never really heard of it until like 2 months-ish ago. But, like, making this backend was honestly, like, very enjoyable. Like, Go has, there are some things, like, I wish I came with it, to be honest. Like, writing my own contains function, didn't really love having to do that. Something like that, but the rest is like, errors as values is so chef's kiss. And like how easy it is to make structs. It's a great language. Like looking back at the fact that you can just like do this stuff and it all like looks good together. That's good stuff. That's good stuff. Okay, you're planning to rob money from the house. from the houses, but you cannot rob 2 adjacent houses because the security system will automatically alert the police if 2 adjacent houses were broken into. Okay, so you always have to skip. That's pretty much find the max between the skips. Okay. Any resources for writing the backend in Go? Oh shoot. I so do have something that I'm thinking of, but I can't remember the name of it. There was some, well, for one, like, the Go docs are really good. Oh yeah, I also originally did Advent of Code in Go, and this guy's GitHub, or no, not this guy. Is it this one? Yeah, this guy. Alpha 1. This is where I saw like a bunch of how to write good Go code. Like it's very, very clean and methodical of what he does, which is how I learned a lot of this stuff. And then just reading docs, comparing it to other things. It takes a while though. It's not the most intuitive language, for sure. Like the for blank and like range or whatever, like the syntax is a little bit weird. But besides, once you get over that hump, it's a great time. And the tests, oh, the test suites are so nice. Okay. So how can we think about doing this dynamically? I haven't encountered this type of dynamic programming, like template. I know this is considered one of the problems that are like a whole thing in of itself. Think about it, I'll let you lock in. All right. I appreciate talking about my projects. This isn't like a LeetCode or die stream. As long as it's about programming, I don't care. Okay. So pretty much at each house, at each valid house, meaning robbing wouldn't set off the alarm. We have the choice of either robbing or not robbing. So maybe explore both paths and take the max from each. So is it actually that simple? Like pretty much what I'm thinking is just like we start our DP that takes in an index. Our index is between bounds of nums. Damn. Then go to then try to explore the max between that siren was ridiculously loud. You're picking that up off my MacBook my MacBook input. Oh shit, what was I thinking? Shit. Trying to take the max between if you were to rob because the thing is you technically don't have to rob the next one, but it's not, since they're always positive, it's not beneficial to not rob one. Like you always want to be robbing on the Actually, no, that's not true. Because sorry, I'm doing a horrible job explaining what I'm thinking, but pretty much, say it's something like this, where it's technically is this a good example? I think. So it's like you need to decide out of these which ones to take, and then from this, like, you have to decide which one of these, because this one maps to that, and this one would map to that. Problem is this, I'm working on like the classic DP problem, house robber, but I've never seen it before. So I'm doing this kind of just raw and guessing. And I'll read the official way to do it after. But I'm just going to see if I can figure it out. Practice, yeah. What's up, Faith? Yeah, I'm on like 10 minutes in. Good luck, keep grinding, thanks. Faith, how's your studying going? I know you got your thing coming up. Okay, so naively, like, I think it's something like this. Return 0. And then return the max of df of I'm just trying to think if there's ever a case in where you would want to, like, skip both. But I don't think there ever is. So I think also we need to check index equals the length minus 1. Then we like can't go past it. So it returns nums at index. About the recurrence relationship, yeah. That's what I'm thinking, but at least what I'm trying to. Nums at index plus df of index plus 2, or nums at index plus 1 plus df of index plus 3. I don't know if this is right, but I'm pretty much just trying to think of, like, you want to check the current one plus, like, checking this. Like, if you are to take this, like the 0th value, then you're forced to move here because you can't check this one out. I think this actually might work. Because it's like you always can either check between this and this, but then you're forced to move here. But then you can check between these two. And then the way I have it is if you're greater than or equal to the length of the nums, we just return 0. So this is if you're out of bounds. Obviously, there's no value here, so we're just going to return 0. And then if you're here, you don't have a choice. Yeah. Because here you can pick between like the length -2 position or the length -1 position. So you do have a choice, but here you are locked to one choice. Let's see. I didn't comment this out. Oh, it's not like... I thought in LeetCode you could just stick an @cache on it. Is that only a LeetCode thing? I think I can just stick an @cache on it in here. Let's put an operand list and int. Wait, index should always be an integer. Wait, what? Oh, yeah. I always do that. Hey. Yeah, that wasn't bad at all, actually. There's probably some things you can do to optimize it, so let's try to read it. You do tabulation. Should probably try to figure that out. This is just always the easiest way that I think about things, but I should try to figure out, like, before reading these, of how to so I know, yeah, the occurrence is fine. I do need to work on the tabulation though. So for tabulation, I'm pretty sure you always want to do like length +1. Do you want to go backwards though? No, I think you still want to go forwards. Because as you iterate through, what are you reaching back for? Or, so what's something we can do is memo at 0. We can define memo at 0 and memo at 1. If they're there, though. Nums will always be at least of length 1. I'm gonna do just a cheaty thing of the length of nums is 2, then return the max between nums at 0 and nums at 1. Because I kind of need it to have at least these two for the memo. Or no, is that right? Because I'm thinking you want to reach back. But I don't know if you're supposed to reach back. Because how are you supposed to... Because like the max between these two are always fixed. So we can fix that in our memo thing, because it's either going to be you pick this or you pick this. They don't come from anything else. But then it's like at here the max can be the value at that position plus this. Or how's the other way to get to it? I'm having a really tough time transferring this to this. Because for this we're always looking, we want to calculate the next one. So it's almost like, do you want to do it backwards? And just compute the ones at the end? I don't know. And I want to have time for do another one, so unfortunately I'm going to give up. I should probably read through this whole thing to figure it out. The recursive, yeah. This is still recursive. Okay, so iterative. Oh, interesting. You set it to 0. And then the first one is that nums. And then you iterate from... Ah, it's so simple. That's so simple. Why did I not think of that? It's just hard for my head to go from recursion to iterative. Oh, this is even smarter. I mean, the good thing is, this is making sense to me. Bad thing is, I couldn't make sense of it creating it. Alright, well, might as well type it out. Ooh, why do they do this actually? Because length of nums is always 1. Or at least 1. Or no. You want to compare plus, or just prev1, right? Of course. Because you're just comparing the current value to if you were to step back 2 and add it. Okay. Do I want to do one more? I probably should. These have not been my best ones. Second. Okay. We're given a string S consisting of only uppercase English letters and an integer k. You can choose up to k characters of the string and replace them with any uppercase English letter. I prefer forming at most k replacements during the length of the longest substring, which contains only one distinct character. Okay. So it's like this. Okay. Okay, so something I'm thinking of is maybe like sliding window. Like a sliding window with a count of how many distinct characters are there. Like something kind of inefficient is like to keep a set of every sliding window. But I think that would work. And then pretty much just as soon as the set's length is greater, we just move the left pointer. So it's like, what was it? So we like have our L and R pointers, and then we just keep going until we don't need a set. We need to just keep track of the operations, because we can only have k operations. It's not k distinct characters, it's k operations. Okay. So we just need to keep a count of the problem was a 0-1 knapsack for house robber. I've heard that term before. Does that just is that like the same as like a coin change? Where it's just like you either take or don't take pretty much? There's different types of knapsacks. I'm gonna end items for you. I should probably study like take or skips essentially. Yeah, okay, that's what I thought. No, not types. What is it called? Not types of problems. Categories, maybe? No, I don't want like top down and stuff. Yeah. That's ChatGPT, I probably should. Alright, let me focus on this problem and then I'll go back to that. I think it's just a sliding window though. And then it's just like we pick the first index to be our given, like this is, if anything's different than that, then we call it distinct, and then that's considered an operation. And then once we're at a certain point, we would just walk this pointer back until we got to a different one, and then start a sliding window from there. I think I have a good idea how to do this. Famous last words. Okay. Well, that was less than R. Sorry, I just have to respond to someone. What the fuck is he saying? Oh wait, I don't think this is called a sliding window. I think this is two-pointer, right? Oh no, it's sliding window. How is it a sliding window? I'm gonna just do it the way I thought, and fuck the technique, I'll learn it later. I was actually always gonna be less than R. And the length of that. We're gonna do I always have a length of 1. Okay. So we're gonna need to keep track of our current operations too. Operations equals 0. So while L is less than the length of that, we're going to start walking our right. So whereas the S at L, and then while R is less than the length of S, and for operations is less than or equal to K. But how do we ever walk the left pointer? I just don't understand. I don't have a good mental mapping of the technique that I'm thinking of. Which is bad, because this is a very basic technique. Check a hint. That's probably a good idea. Characters would you replace in a string to make them all unique? Frequency map? Okay, that's like what I'm thinking though. This is what I'm thinking. Pretty much exactly. I might have worded it wrong, but that's what I'm thinking. I was thinking like you take this and then you keep expanding your window until you have k operations. And then you just push the other pointer back until you get back to it. But I just don't know the structure of it. But I can probably figure something bad out. Okay, left pointer variable and an R pointer as a for loop. I see what you mean. Something like that. And then I think we keep the same type of thing of there at there. And then or do we want that outside and then we change if asset R is different than asset L in our core operations plus equals 1. Res equals max between the res and the length of the window. So is it just R minus L? Is it that plus 1 though? Because like if we have, so we have AB, that's 0 and 1, but this is a length of 2, so I think we need a plus 1. I think. Might be wrong about that, but if S at R is not equal to, then our recur operations is going to be greater. So then we want to move if recur operations is greater than K, then we want to move until we're not at well, S at L is equal to the original. I'm just gonna just move the left pointer and then subtract 1 from the cur operations, and our R needs to reset, right? Nah, something about this feels wrong. Just thinking about it in my head. Because if the current person is greater, then we need to move the left pointer over. But that doesn't mean like all the A's are gone, because like there could be another A here. So I think we need to reset the R. But I don't know if I'm allowed to do that. Fuck, what an off day for me. What an off day. Like, this is what my mind wants to go to. But I just don't think that's right, so whatever. Why do you need a character set? Oh, you're just making it a set. Okay. So you're looping over the characters in the set. Count as... I guess I should probably look at the optimal sliding window one. So our count map is 1 plus the frequency. And then our map is going to... our max... is the max between the value and the given map. Okay. Well, R minus L plus 1 minus the max frequency is greater than K. The count subtracts, okay, because that's like the length. We're subtracting length and we're adding. Shit. Wow, that's really hard, actually. I would not have come up with that even remotely. Damn. Bad day for me. It's quite stupid. This is... Is it frequency? No, it's like a length mapping. Never, I haven't done one of these problems in a while. Can't get too upset. But I can. God damn it. So I counted R. Classes start yet? Yeah, I've been in classes this whole week actually. I just got my schedule finalized, and it's better than what it was going to be like a day ago, which is really nice. I got into my networking class instead of a security class, because the security one would have been a bitch. What classes this semester? I'm taking computer architecture, systems networking, a poli-sci class, and then a data engineering class. Just 4, because I'm also doing two part-time jobs. So I have like 20 hours of work and then 4 classes. Good stuff. A hustle? You gotta hustle. I need money to pay for my housing next year. Unironically. That, and also I just need experience. So like, one of my jobs is a desk job, which like it's like no work. I just sit there, I do homework, other work, and that's about it for that one. But the other one is a part-time internship, which is not like exactly a software engineering role per se, but like experience is experience, and who am I to say no? So. Enough of that. I've been doing that for an hour. Oh my rightness. I actually don't need that anymore. What do I need? I need JSON would be enough. Okay. I don't know who all is here. If they were here yesterday. If you guys were. But essentially, what we finished up yesterday, and a little bit of today, while I was in class, was we have a lexer now, or like a tokenizer, for JSON, which is it's actually quite cool. So it was quite fun to do this. But essentially, what we're able to do is take in a string like this or a file, and then call tokenize on the input. And then what that does is it gives us tokens of these types. So it's either like a string, a number, a boolean, a null, or like an indicator to like, if it's a brace, then we know it's an array. If it's a bracket, we know it's an object. Comma's a separator, colon's a separator. And this came out quite well. Got all the tokens. So like, if it's a colon, it has a value of colon, and at the line and column for debugging purposes, which is cool. So I'm quite happy with how that turned out. I'm realizing one thing though. Is Vim your first IDE? No, I used VS Code for the first. Actually, technically, in my APCS class, we used something called BlueJ, I think, for Java. And then I used VS Code for a while. Yeah, BlueJ is kind of a throwback. Yeah. So BlueJ and then VS Code for like a year, and then I got to the point where I was customizing my VS Code so much to try to have it do what I want that I watched a couple videos on NeoVim, and I was like, yeah, fuck the deck. Dude, that's what I'm saying. Fuck that shit. Okay, what was I doing? Self.line. Yeah, here, I also want to reset the column to 0. Which should actually make this a little bit better. Yeah. Nice. Nice. So, essentially it's like, if we go, we see these things is like matches up with the line and column, which is cool. It's cool stuff. So now our job is to take all of these tokens and pretty much make a dictionary in Python, which, yeah, it's not a whole lot of others to say. I don't exactly know how I'm going to do it, but like, let's just start. So I know I'm going to need a parser. Or this should be a class. And what am I giving out from Elixir? Class. I just need the tokens, right? So I think our init is actually just gonna take in tokens. Do I want it to take in tokens, or do I want to take in like a possible source and then call the Elixir on it? I'll figure that out later. I don't think that's an important decision. For now, I'm just gonna have it take in tokens. And I'm gonna need to take in from Lexer import token type. Because then this is of type token. There's actually gonna be an array of token. I think that is how you do it. I want to say, yeah. Why am I setting that up? So then it's just self.tokens equals tokens. I think we're gonna need a self.position. So probably like a current equals 0. This is just like the index to the token array. Do we need anything else? Okay, that kind of seems fine. Right? And then it's pretty similar. It's just like match the token types. Oh, we should need a self dot like result, like what do I call this? Self.json? Like it's the resulting thing. Any ideas? I'm so bad at naming things. I might just call it JSON for now, or self.result. Self.res equal that, sure. We'll just call it that. We'll rename it later, I guess. Def parse is going to return a dict. So at the end, we're going to return self.res. And then I think we need pretty much something similar of like the while not self dot. Is it end essentially? Like parse the token, just kind of spitballing. So then we can actually just take this from here. Except it's not source, it'd be tokens. Right. So now if we parse the token, this is going to return what would this return? It's going to return a token, but is it? Or no, it's not. It's going to be void. Because we're just adding it. Right? Yeah, I mean, it's like incredibly similar to this. Where we're just pretty much doing probably just should make like a peak and everything. I'll just take all this stuff for now. I think probably will be useful. this is actually going to be of type token. Actually, don't need token type. I'll keep it for now. Turn none. So I don't want it to return a blank token. So I guess for now, can I do like an optional? Yeah, cool. This is my first time doing type checking with Python. It's honestly quite cool. And this is tokens. And then all advance is going to do is trying to think of, do I need a bounds check on advance? I'll just put a comment for now. Do I need a bounds check? Because could it be optional? That's what I'm trying to think. I don't think so. Because I think kind of similar to how we did the lexer before we advance, we're always going to be checking if we're at the end or not. So I think it's fine. Okay, so cur token equals self.peak. And then just match the cur token dot type. So in the case that it's I don't want to rush into this actually, so I thought about it. So it's pretty much like if we interact with like a number, trying to think. If we interact with, it's pretty much, I need to think about what tokens make us do what. I think we first need to be checking, really the only thing we need to check in the token is if we're hitting all right, my struggle is coming from, I don't know. I'm going to have to always look at the left side only of JSON, right? Because like a JSON example, or I have one actually. So it's like, given my tokens, I'll have this hit first, and then so once I hit that, then I'm going to have to expect a string. And then I expect a colon. And then from there I expect either a primitive or a container. All right? So then it's pretty much just like for the right hand side, I have to match if it's a string, I just do this matches to that. Will that work with this recurder? Yeah, because then if I interact with something like an object starter or an array starter, I then will make a method called like parse array. I think. All right, we'll try it out. So the essence is, the things I'm actually looking for is this and this. Right? Yeah. Car token. Okay, so we want either token type dot either a left bracket, and if we're hitted with, if we get a bracket, then we want to parse object. If we have case of token type left brace, then we parse the array. And in the case of string, then we self.parse member. I'm pretty much just following this. Right? I'm kind of just spitballing. I don't really know what I'm doing. But that is not new. Right, let me check one thing. Okay. Do I believe that this is the right way to continue? Think so? So like, let me put out a skeleton for what parse member might look like. So member expects a JSON element, which is either a primitive or a container. So maybe I make a method called like is primitive. And then just return self.peak token type in token type dot stir number boolean. Because peak can be optional. Peak being optional is kind of fucking me right now. Oh wait, don't I have a null value actually? This might come back to bite me, but whatever. Oh, but it's not an actual token. What if we just hit the game remove of removing the check? No, that's real bad. Or I can just have this taken a token, I guess. I don't know if this is the best solution, but it's kind of all I can think of. Would be the queue? I don't know what you mean by that. But if you mean what am I doing? Making a JSON parser. Okay, we made the lexer. So I've tokenized objects. Like pretty much what we have is, yeah. This is in terms of just tokens. Now I'm working on the part where it's like, now I have tokens. Can you make the map, like the dictionary, pretty much? And I kind of haven't read anything about doing this, so I'm doing it kind of blind, which is never good, but, you know, like, whatever. Gotta make the square. I need to stop talking while I'm trying to focus. Gotta make the square wheels to appreciate the round ones, you know? So to parse a member, that means the current token like left side equals I'm gonna remove these for now because I'll deal with the bounds errors in a little bit. But right now I don't want this to yell at me continuously. I don't actually think we're going to need peak 2 tokens. Might not need. Anyways, so the left side is just self.peak. And then our right side can be either, we'll then advance past that. And then our advance actually returns this, so we should do advance. And then after that, we need the next token to be a colon. So if not self.peak equal to, or if that token type is not equal to token type dot colon, we want to raise an exception. Raise exception, expected colon separator, while parsing member got self.peak. Okay, so now we're fine to move forward, which means we then need to match I actually just need to call parse again. The only thing I don't think is, like, you can't have that, right? Yeah. Which is why this is fucking me up a little bit. Like, this JSON is either a primitive or a container. I think what I'm going to do instead might not be the best solution, but we would then we always want to advance past. No. It should stay as peak. Advance past the colon. And then if self.peak, so if the current right side self.peak, if right side dot token type in, or I just wrote a function for this. If right side dot, or if is primitive, then we want to self.parse just call this like next token. Because pretty much what we want to do is either parse a primitive and then set our result left side equal to the primitive parsed value, or we need to set res at left side equals self.parse primitive. Right? And then else we're in one of these. but it can really only be one of these. So I should make another one of, if it's a container, def is container. I think it's, whatever. Turn token type in token type dot left brace left bracket elif self dot is container self dot res at left side is parse container else raise exception expected right side of member v of type primitive or container got next token. I'm building a JSON parser. So right now we have like given some JSON input, either from like something as simple as a string or like an actual JSON file. We then can tokenize it. So like you see a string of leading 0 then matches to a number that comes from here. Leading 0, then we have a colon that matches to a number. So that's all the tokens. And then now that we have all those tokens, we're trying to build the map. So pretty much build this, but in Python's like a dictionary. This is the goal. And I'm following this called a Backus and Hour form to define the structure. No, it is just going to be a dictionary. That's exactly what it's going to be. But there are a lot of rules in JSON that you have to follow of like what's valid JSON. So you can't just naively put everything of the string in it. You got to first check everything. Okay, where were we? See, thanks. Yeah, of course. Thanks for stopping by. Okay. I think there's questions like this on Great Front End. Have you used that? I don't know what Great Front End is. Okay. So now we've parsed a member. Do we return anything? Don't really know. But we can make like a parse primitive and just keep rolling down. Or I guess I'll put it under it. Def parse primitive. Parsing primitives should be as simple as this is actually a question, is if I call int on -1, I do get -1, so I can pass negatives. Cool. If I call int on something that has a dot, though, I need to call a float on it. Okay, that's good. Good to know. Okay, so token equals self dot peak. If we somehow get to it not being a primitive, we want to raise an error. Expected token to be primitive. Got token. Okay, and then we want to match the token dot token type. And this is going to return either a string or an int or a float or a boolean are the options. In the case that it is a token type of str, we're just going to return token.value, because it's already a string. In the case that it is a bool, how do I actually keep track of booleans? I kind of forget. The best way to actually figure that out is just do so it's a type true with just a value of true, like the string. I think I can just do token.value then. Okay. And then in the case of token type being number, we need to first check if there's, or actually, let's just return int can you cast to a bool? Is that something I can do? Okay, cool. But if I do this, that's bad. Okay. So return true. Or actually, I can just do this. Return int token. do you do that? String contains method Python. Find. Oh, just in. Okay. Okay. Cool. Return int or return float if token dot if our dot in token dot value else cast it to an int. I think. What is this error yelling at me for? Why is it saying it's none? Oh, because I should just do case default. Okay, I think that is fine. Peak. And then token equals, we gotta advance it. Okay. We need a way to handle commas as well. Maybe we treat commas as like after each one we expect a comma. I'm actually not sure. I'll worry about that in a little bit. This might be a bitch. I think I actually might stop here. Anything else I do is going to take like a good amount of time. I think we got a decent skeleton going though. Decent skeleton, I think. Yeah. I'll call it here. And then tomorrow, should finish the parser. So yeah, see you tomorrow for day 26. Bye.